This is my final presentation for geometry, Quadrilaterals Explained by Seth Moses. So, what is a quadrilateral? A quadrilateral is any closed shape with four sides. Quadrilaterals include parallelograms, trapezoids, isosceles trapezoids, a rhombus, a rectangle, and a square. And we're going to go through each one of those and find the properties. I'm going to explain the properties and just how they're built. So let's start with a parallelogram. Parallelogram opposite sides are congruent. So you can see line A and B is congruent to line DC. Same. And then opposite sides are also parallel. So line AB is parallel to line DC. Same with line DA is parallel to CB. And then opposite angles are congruent. So angle DAB is congruent to angle BCD. And then we have congruent angles are supplementary. So that means the angles next to each other are supplementary. So angle DAB is supplementary to angle ABC. Those two angles add up to 180. Diagonals bisect. You can tell by the tick marks on this image that I added that since they're equal on both sides, diagonals are cut directly in half. Next, we have a trapezoid. So with the trapezoid, the baselines are parallel. So the baselines are they're not really labeled very well, but this bottom line and then this top line, they are, so I guess you could say line A and B are parallel. And then the leg angles are supplementary. So that would be the angle in between line C and line A. This angle right here is supplementary to this angle. And then same over here, supplementary. And the mid segment is parallel to the bases. So this line right here in the middle is the mid segment. It's parallel to line A and B. It's mid segment because it cuts the whole thing directly in half, making two equal halves of line C and line D. Next we have the isosceles trapezoid. So the isosceles trapezoid has all the same properties as a normal trapezoid and then some. It has the legs are congruent, so that's wrong. The legs are not congruent. The legs are parallel. Oh, I'm sorry. Yes, the legs are congruent. The legs are the lines on the sides. They are congruent. And then it also has the base angles are congruent. So then this image isn't labeled very well, but this top line right here on the top half, it's parallel to this bottom line. That's another, but that's just all trapezoids. But it's also the angles to it are congruent. Right here, you can see, and the angles right here. And then same with the bottom. This angle is congruent with this angle. And then the diagonals are congruent. Diagonals are the same, as you can see. Now we have the rhombus. So all sides are congruent with the rhombus. Each side, you can see side line DA is congruent to, well, all of them, AB, BC, DC, and Also, opposite sides are parallel. So line DA is parallel to line BC. They're parallel. And then all angles are congruent. So that's this angle is congruent to the angle directly across, also congruent to angles. So DAB is congruent to angle ABC and angle BCD and angle CDA. All those angles are congruent. All angles, so the diagonals bisect at 90 degrees. You can see the diagonals bisect in the middle, directly in the center of the rhombus, and they are perpendicular to each other, so they equal 90 degrees straight across. Next we have the rectangle. Opposite sides are equal and parallel. So this one's not labeled at all, really. So I'm just gonna point it out. The top line is parallel to the bottom line, and it's also equal. They're the same length, congruent. And then same with the sides. The side line is parallel to the side line on the right, and they're congruent. And then all angles are 90 degrees. The interior angles. So this angle right here, they're all 90 degrees. And then the diagonals bisect and are congruent. So there are no diagonals on this, but just imagine if there were two lines going straight across from this corner to this corner and this corner to this corner. They would cut each other directly in half, and they're exactly the same length. Alright. Next is the square. The square has no properties of its own. The square takes properties from the other shapes, and none of them are original, because the square is a phony. And you can see that starting with diagonals bisect at 90, that's copycat of the rhombus. Diagonals, so there are no diagonals on this, but if there was a line going from this corner to this corner and this corner to this corner, they would cut each other in half, and they're also congruent. And then the diagonals also bisect the angles. You can see, so if you imagine a line going from here to here, cuts that angle directly in half. So if this angle's 90 degrees, it would, whenever the diagonal goes through it, there would be 45-degree angle here and a 45-degree angle here. Cuts directly in half. And then opposite sides are parallel. So the top line is parallel to the bottom line, and then the right line is parallel to the left. And then all sides are also congruent. Each side is the exact same as the other. And then opposite sides are parallel. We did that already. And all angles are 90. Did that. So those are the properties of the square. Alright. Now let's talk about why is it important to know your quadrilaterals. Well, number one, communication. It's important to know the names of really all your shapes. And it helps to know them more specifically because say you are at a job and you're, I don't know, moving tables. Maybe you're just working for a church or your community. You're moving tables. Someone tells you, could you go get that square table? Well, you need to know what a square is for so that's why it's used for communication. Because if you don't know the names, then you really just can't help. And then also identification. So if someone tells you go get that square table, you don't know the difference between a square and a rectangle. I mean, you might bring over the rectangular table and just look like a dodo. So it's important to be able to know your quadrilaterals so that you can identify them because they're used on a daily basis. I mean, I'm sitting at a rectangular table right now. I mean, these quadrilaterals are everywhere. So that's why it's important to know them, because anything that's used, that's seen on a daily basis, obviously is relevant to your life. So you should understand it. And that's my presentation. I'm Seth Moses. Thank you.